Hello, you are welcome to this math tutorial from Genie Professional Services. Today I will be talking about number systems. Number system can be defined as the basis of grouping the numbers we have in mathematics. We can also describe number systems as a system of counting numbers according to a particular number. That is the leading number. This leading number is the highest digit in a given number system. We have different number systems such as denary system, also known as base 10, binary system, also known as base 2, octal system, also known as base 8, geodecimal number system, also known as base 12, hexadecimal number system, also known as base 16, etc. In our basic education, we are only taught denary system of numbers, that is base 10. I know we are all conversant with tens and units, hundreds and thousands, all the addition, subtraction, multiplication and division, etc., which are done in basic education, are in base 10. Today, we'll be talking about binary system of numbers. Binary system of numbers is used in all forms of switching applications. In binary system, the only symbols or numbers counted are 0 and 1. This is because 2 is the highest number in the number system. It means you cannot count numbers such as 3, 4, 5, etc., which are above 2 in binary system. Numbers above 2 are expressed or written using 0 and 1. In binary system, the place values are in powers of 2. We will be converting numbers from base 2 to other bases and vice versa. Example 1. Convert 1011 base 2 to base 10. Solution. We are going to solve the above example by finding the place values of each of the digits. Then, we will multiply and add up. The place values of the digits given above, counting from the right, are 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and 2 raised to power 3. When finding the place values, we start numbering from our right hand side, and we start with 0. If the number given has a decimal, we number the digits after the decimal from the left, beginning with -1. Since we have found the place values, that is the powers of the base of the given number, 1011 base 2, the next step is to multiply and add. So we have 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. This will give us 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. This will give us 8 plus 0 plus 2 plus 1. This will give us 11 in base 10. Therefore, our answer is 1011 base 2 equal to 11 in base 10. Note, any number raised to the power of 0 is 1. Let's go to example 2. Convert 1101.101 in base 2 to base 10. Solution. We will place the values of the digits in powers of 2. We will do that of the digits before the decimal point, then we will do that of the digits after the decimal point. When we have done this, we will multiply out and add up. The place values of the numbers before the digits are 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and 2 raised to power 3. The place values of the numbers after the decimal point are 2 raised to power -1, 2 raised to power -2, and 2 raised to power -3. We have found the place values of the digits in powers of 2. Now we are going to multiply out. For the numbers before the decimal point, we have 1 times 2 raised to the power 3 plus 1 times 2 raised to the power 2 plus 0 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. This will give us 8 plus 4 plus 0 plus 1. This will give us 13. For the numbers after the decimal point, we have 1 times 2 raised to the power minus 1 plus 0 times 2 raised to the power minus 2 plus 1 times 2 raised to the power minus 3. This will give us 1 times 1 over 2 plus 0 times 1 over 2 squared plus 1 times 1 over 2 raised to the power 3. This will give us 1 over 2 plus 0 plus 1 over 8. When you add up, you have 5 over 8. The next step is to add up 13 and 5 over 8. When we add up 13 and 5 over 8, we'll have 13 whole number, 5 over 8. 5 over 8 is the same thing as 0.625. Therefore, our answer is 13.625. Therefore, 1101.1012 equal to 13.625 in base 10. Example 3. Express 23, which is in base 10, in base 2. Solution. When converting from base 10 to base 2, we will divide repeatedly by 2. We will keep record of the remainders. When we have got 0 as a quotient, we will stop dividing. We will write down the remainders from below to top. This will be our answer in base 2. Now let's do it. 2 into 23 is 11, remainder 1. 2 into 11 is 5, remainder 1. 2 into 2 is 1, remainder 0. 2 divided 1 is 0, remainder 1. Now we're going to count from below to top. We're going to count the remainders from below to top. Counting from below to top, we'll have 10111. Therefore, 23 in base 10 equal to 10111 in base 2. Now let's do some exercise. Express the following numbers which are in base 2 in base 10. A. 1110. B. 10111.011. Number 2. Express these numbers in base 2. A. 25. B. 11. Thank you for being part of this class. See you next week.